In today's session, we will see how to develop your first trading algorithm and how to do the backtesting of the same. So if we talk about backtesting, then why backtesting is required? Backtesting is required to check your trading strategy or verify whether it will perform good in the future or not. That we can do by verifying this in the historical data. So we will run the trading strategy in the historical data and see how it performed in the various market scenarios. On the basis of that, we can anticipate that how it will work in the future as well. So what is required to do the algo trading? What is required to develop the algo trading backtest? So let us list down the things. First thing, you need to have the strategy in the hand. So strategy has to be there. Some trading strategy, some logic by which you want to do the buy and sell trades. You need to have historical data. And once you get the historical data, you need to verify, you need to implement the logic. And then you need to verify it. So these are few steps which are required to perform the backtesting. So first thing, we need to import, we will develop this trading strategy and backtest in the Python. So first thing, we need to import all the necessary libraries. We will be importing the data from yfinance. For yfinance, we need to first install yfinance in Colab. I'm installing pip install yfinance. I would like to tell you, Colab is a platform which is provided by Google. If you have Google account with you, anybody can go to Google Colab and start developing the algorithm here. So it provides the basic libraries installed already there in this. So you like pandas, matplotlib, numpy, etc. are already there in this framework. You don't need to install that. But yfinance is a third-party software, third-party library that you need to install it in this. Let us install yfinance first. It will take a while. It is installed. Next thing would be to import the same library, yfinance as yf. I expect you must be having the basic knowledge of Python to follow this session. We will import few more libraries, basic libraries like pandas and numpy. So we have imported the basic libraries. So first thing, we need to have the data in the place. Let us import the data first. Let us take a ticker called Reliance. We'll develop the strategy on Reliance. The ticker name in yfinance for Reliance is reliance.ns. So in Y Finance there is a function called download, by which we can download the data. It has few more parameters like the frequency and the period. So if you don't give the period, then it will take the maximum. If you can see, default is period is maximum and interval is 1D. 1D means 1 day. So we can give that, or we can just skip it. Then in that case it will take the maximum period and it will take the frequency as interval as 1 day. So that data is downloaded. Let us see how the data looks like. So it has taken data starting from year 1996 till now. Wonderful. It is good amount of data to do the backtesting. We will be performing the backtest on close price. So adjusted, you can see there are two close prices. One is close, another is adjusted close. Adjusted close is nothing but when the stock splits, it gives bonus, it gives dividend. Then it's adjusted close actually adjusts the close price accordingly as per the split and bonus and dividends. So we will be using adjusted close. So for simplicity, what I will do, I will update df close to df adjusted close. And as we discussed, we will be using simple moving average crossover for developing the strategy. For that we need two parameters. One is long simple moving average, another is short simple moving average. So if simple moving average short goes above simple moving average long, then we have to go long. We have to take long position, otherwise we have to take short position. But in this session we will focus only on long strategy, not on the short strategy. So let us say we have to define two periods. Long period is equal to, let us say, 50. Short period is equal to 10. Let us run it. And let us define one more column called transaction date, which we will be using later in the algorithm, is equal to pd dot to date time df index. I ran it. Now let us define our simple moving averages. So I will create two columns, SMA long is equal to df close dot rolling long period dot mean and I just copied this for simplicity. SMA short is equal to short df close again rolling period of short period mean. Let us run it. Wonderful. Let us see how does it look like. So our data frame looks like this now. Let us drop all the values where SMA long and SMA short is not a number. For this we will do df dot drop NA in place is equal to true. And let us develop the strategy as of now. So our strategy was if SMA short is greater than SMA long, then we'll go long, otherwise we'll go short. But we'll not develop the short strategy. So signal will be df as df dot SMA short is greater than df dot SMA long, then position will be 1. 1 means going long, otherwise -1. -1 means exiting from the position. Let us see how it looks like. If you see, we have got the trades, multiple trades. It is giving the position whether we have to go long or short. So but the thing is, the signals are getting repeated every day, so we need to remove the multiple signals and we have to filter it off on the trades when we have to take long and when we have to exit. For that, let us define one more column called trades. So what we will do, we will remove the duplicate signals, repeated signals. Df dot signal, if df dot signal is equal to df dot signal dot shift 1, it means if the signal is getting repeated, then we'll make the signal as 0, otherwise we will retain the signal. I hope it is understood. And after that, let us make one more data frame where we will keep only the trades which are there in that data frame. We'll remove the signals which are wherever it is 0. df trades not equal to 0. So let us see what is the data is there in df trades, and let us now, if you see in the trades, we have 1 minus 1 1 minus 1 mean 1 means we have to buy, minus 1 we have to sell. So it is very simple now. Now let us define what will be the buy price and sell price, buy time and sell time. So buy price would be, let us define sell price first. Sell price will be np dot where trades is equal to minus 1. So whenever the trade is minus 1, we will be selling it, and we will take the close price of that time. Otherwise we will keep it 0. Similarly, for buy price, as we see that buy signal is just before the sell signal, so we will do like that. df trades dot close just before previous close price will take, and similarly we will define the sell time and buy time also. So sell date would be, condition would be same, we will take it transaction date, and here we can't keep it 0 because it is a date column. We will say pd dot nat, not a time. Let us run it again now. It is showing some error. It is a dot here, I removed it. It ran. Let us see how it looks like now. df trades if we see we have made an error. Instead of buy date, I wrote the buy price. I corrected it now. Let us see it again here, how it looks like. If you see, the date format has changed, so I will correct it again now. So buy date is equal to PD dot to date time and same I will do it for sell. Let us see how it looks like now. DF trades. Oh. So now if we see the buy date and sell date is updated properly. So now let us keep the rows wherever only buy price and sell price both are there. Otherwise we'll remove it. So we'll do one thing, we'll put a condition df trades dot buy price is greater than 0. This is one condition. And df trades dot sell price should also be greater than 0. That will filter on dot copy. And next let's keep this data frame as only the transaction data. Let's remove all other columns. So we'll keep the buy price, the sell price, buy date, sell date. So that will make us a trade book. Let us see how our trade book looks like now. So we have all the necessary columns: buy date, sell date, buy price. Let us calculate the returns now, percentage returns. So for that we need to do like this: sell price minus buy price so this will give us the returns. Percentage returns for each trade. But let us round it up. np.round to 2 decimal places. And let us calculate the cumulative returns also. This will be percentage returns which are cumulative. Let us see how our data frame looks like now. So it looks good to me. So if we see, it's just giving approximately 406% returns, which is not too bad, and 86 transactions are there. Let us see how the graph looks like now. Percentage return cumulative dot plot. So this is how the graph look like in 86 transactions over a period of around 24 years, which is not too bad. So this is how we can do the backtest. This is very, I would like to say, I didn't cover the many other parameters like slippages, transaction cost, etc. because this is the first step, this is the first trading algorithm for the beginners.